Hello and welcome to the Hydrocarbon Engineering Podcast, where we share short, insightful interviews with experts who shed light on topics that matter to you and your business. I'm your host, Callum O'Reilly, and here we bring you the third in a series of episodes with Owens Corning that have delved into factors that can support the performance, safety, and longevity of insulating systems installed in hydrocarbon processing environments, including cryogenic facilities. In this episode, I am joined by Alec Cusick, Owens Corning Technical Lead, Technical Insulation. In this episode, we're going to be talking about protection against LNG pool fires. I hope you enjoy.
The Hydrocarbon Engineering Podcast is brought to you by Owens Corning FOAMGLAS Insulation. From managing vapor drive and mitigating corrosion risk, to maintaining thermal performance and supporting safety on the job site, the insulating system plays a critical role in high-performing hydrocarbon processing facilities. Learn more about how FOAMGLAS insulation contributes to the design of high-performing insulating systems at cryogenic facilities at www.owenscorning.com/FOAMGLAS LNG That's www.owenscorning.com/FOAMGLAS LNG study.
Welcome, Alec, and thanks for joining us today. To kick things off for us, please can you tell us a little bit about your current role and responsibilities at Owens Corning?
Yes, hello, Callum. Thank you for having me. My name is Alec Cusick. I'm a technical lead at Owens Corning for our industrial foam glass team. We are basically a team of engineers that support the sales and specification efforts of our insulation systems. We help with things like specification guidance, application training, and myself specifically, I manage a lot of the PFS requests, which we'll talk a little bit about today, and I help design this system to be used within LNG facilities.
Great, thank you for that, Alec. So, facilities that process and store hydrocarbons such as LNG handle large amounts of flammable materials. What sort of planning goes into building these facilities to help support safety in the event of a cryogenic spill?
Yeah, that's a good question. It's widely known that LNG is a flammable, can be considered a hazardous material. It has to be kept below its boiling point in order to remain in the liquid state, and that's around minus 162 degrees Celsius. So when you're storing flammable materials that are kept this cold, there's inherently a risk in which if a fire were to break out in the facility or a leak were to occur, you have to design your facility in order to mitigate some of the risks of those types of unlikely but serious events. So there are a lot of practices around designing certain parts of the facility to be passive fire protected so that the structural components can maintain their integrity in case a fire were to break out. But also, facilities need to plan for the worst case scenario of a spill occurring of these materials. So a lot of the times, adjacent to storage tanks or large stretches of process piping, you'll actually notice that these facilities have what are called impoundment basins, which are basically large concrete swimming pools in the ground for the sole purpose of, if there's a process spill, the material, instead of flowing along the floor of the entire facility, it'll collect and pool into these pre-designated basins so that the LNG can be safely contained in one area and not run amok amongst the facility.
So are there risks associated with these LNG impoundment basins that you mentioned?
These impoundment basins basically solve one problem, but they can introduce another. So as we mentioned, LNG has a very low cryogenic boiling point. So in the event of a spill, you basically have this basin that's full of very cold LNG, and it'll rapidly start to heat up and boil off as ambient temperatures from the environment convert the liquid into its vapor state. Now, LNG is actually only flammable in its vapor states or in concentrations of around 5 to 15% by volume. So as these vapors were to escape an impoundment basin in the event of a spill, there becomes a fire hazard from that in of itself. Because if these vapors were allowed to drift away from the impoundment basin, come across a faulty piece of equipment, a nearby parking lot, or some other ignition source, it's actually possible for the entire impoundment basin to catch fire. And now you have a large amount of LNG, that's fuel, that is rapidly converting to vapor and generating a lot of heat, a lot of radiant energy from this fire. So there's a lot of risks, because if this fire is allowed to break out in a large impoundment basin of LNG, the heat from that fire not only can be a danger to nearby personnel, but it could compromise other nearby equipment. Let's say you have other adjacent tanks, other process piping or structural steel. You basically want to make sure that any heat generated from a fire is not going to compromise other aspects of the facility, which could be what's referred to as cascading events, where a fire in one part of the facility compromises another part of the facility and leads to a domino effect of cascading reactions.
Okay, so what methodologies are typically used to mitigate some of these risks then?
So there are multiple approaches that facility owners commonly take today to mitigate against these types of cascading events, as we mentioned. There are active solutions, which are systems that are implemented that require activation via some external source, whether that's an operator who flips a switch or a sensor that detects there's a problem and activates. That could be in the form of fire water systems that spray water on critical equipment, or high expansion foams that generators that turn on. But there are also passive solutions that require no external activation. Basically, the function of a passive system is solely dependent on the system's design or materials that are used. So some examples of that are fireproofing nearby equipment so that they're protected from heat in a fire. You could actually physically move the impoundment basin away from critical equipment if you have enough land for it. And that's a passive solution, because now your source of your fire is away from anything that might need protection. But also, we're going to talk about our system today, which is the pool fire suppressant system, which is actually a means of insulating the impoundment basin itself and limiting the heat that could emerge from a fire should it occur.
Okay, Alec, can you tell me a little bit more about the recent testing that was conducted on the FOAMGLAS pool fire suppressant system?
Yes, we'd be happy to do, Callum. This was something we conducted earlier this year, where we conducted live LNG pool fires at Texas A&M's Brayton Fire Training Field in order to determine the effects that our FOAMGLAS PFS system has in a real LNG fire scenario. So we actually conducted 2 live LNG burns within their largest impoundment basin. The impoundment basin was about 21 feet wide by 33 feet long and 4 feet deep. For each burn, we basically poured about 5,500 gallons of LNG within the basin, which was around a foot of depth for each. And then one scenario was unmitigated, so an open basin. And then the second scenario was with the PFS system applied, so that the PFS system was floating atop the LNG before we ignited it. Then for each burn, we ignited the LNG. We used a thermocouple tree to measure what the burn rate of LNG was throughout the fire. We used a series of radiometers surrounding the basin to determine how much radiant heat flux was being picked up by the fire. And we had 2 calibrated cameras recording in order to determine how large the fire was and determine how much smaller the flames got with the PFS system applied. On conclusion of this testing, what we found is that with the PFS system installed, we saw about an 86% reduction in LNG burn rate. That's quite significant. What that means is the PFS system floating atop the LNG was insulating the cryogenic LNG underneath from the flames that were above, and that limited how much heat was able to pass down into the LNG from the fire. So that means that the LNG was being consumed and converted into more fuel for the fire at an 86% reduced rate. This correlated to an average radiant heat flux reading of somewhere between 49 and 69% reduced for the PFS scenario. So if you're standing on the perimeter of a fire like this, you're going to notice a lot less heat coming off, and it's going to be less uncomfortable for you, but also much less dangerous to any sort of critical equipment or structural steel components that might be adjacent to that fire. And then finally, probably the most spectacular part from a visual perspective, we noticed that the fire generated with the PFS system applied had an 87% reduced flame length compared to the unmitigated burn. For the open pit fire that we did, the flame immediately sprouted up to around 77 feet in length on average. It was very, very tall to observe. With the PFS system applied, the LNG pool fire got to about a 10-foot flame length, so much smaller in scale. And that's why we talked about how the radiant heat flux was significantly reduced, the LNG burn rate was reduced. And this is all the type of data that we were looking for to validate the type of performance we can expect. And we're really excited to be able to help assist specifiers, make their process safer and mitigate against these types of fire risks moving forward.
It sounds impressive, Alec. And I was just wondering if there were any other insights around LNG fires that you learned during your week of testing.
Yes, it wasn't expected going into the week of testing, but in talking with the personnel at Texas A&M's facility, one thing that they noticed was upon conclusion of the unmitigated burn, so the open LNG pit with no insulation applied, the decision was made to terminate the test at one point for general safety, and we got enough data. But when the firefighters went to apply the unmitigated fire, they were successful in doing so at first. However, as the flame was extinguished, LNG vapors began once again escaping the basin as they warm up to ambient conditions, and the escaping vapors would repeatedly find some sort of hot surface, whether it was concrete outside the basin or metal of the safety fence that was around the area, and the fire kept reigniting itself as the vapors would drift into hot surfaces nearby. This process actually repeated 5 or 6 times until eventually the decision was made to just let the fire continue until all the LNG was consumed because the firefighters had no means of permanently extinguishing it. Now, this is significant for facilities to keep in mind because while firefighting efforts are very important, if you have a large enough and unmitigated basin, you might struggle, if not be unable to entirely, actually extinguish a fire. So if your game plan against protecting against a fire scenario for an LNG pool fire is to simply show up and extinguish it, it might be worth a conversation around how feasible that might be. Because in our testing, when we had the industry experts on LNG firefighting there and ready to go, they were unable to fully extinguish the unmitigated LNG burn. And that was pretty eye-opening for us.
Yeah, it's really interesting. Thank you for that insight, Alec. So how can these testing results help designers of future LNG facilities meet regulations and make their facilities safer?
Yes, the regulatory bodies that can approve these types of LNG facilities will differ depending on where you are globally. One thing we find, though, is that very commonly you will have to demonstrate that in the worst case scenario of a fire occurring, you have to demonstrate to whoever the approving agency is that you are protected against cascading events like we referred to earlier, where if you have a pool fire occur, you're not going to be compromising other aspects of the facility and potentially having a runaway problem on your hands. So by using the PFS system and having the evidence of this recent testing in hand, oftentimes you can demonstrate to regulators that we are protected against cascading events. Nearby critical equipment will not reach dangerous temperature levels should the worst case scenario of a fire happen. And by using that approach, oftentimes you can demonstrate that your facility is protected and you're not at risk of the worst case scenario turning into something even bigger.
And have these test findings been presented publicly?
Yes, as moment of recording, actually as of this week, we just were excited to present these findings in a technical paper and a technical presentation at the Mary Kay O'Connor Safety and Risk Conference. This is a conference very relevant to the LNG industry. It's all about safe practices using various types of fuels, hydrocarbons. We presented our findings on the data that we got from this testing what it means for the industry. And we actually also partnered with Texas A&M, their Teaks facility as well. They presented some of their findings on the struggles of firefighting some of these LNG pool fires that we talked about. And Blue Engineering also collaborated with us, and they presented the potential to use some of this data in future modeling efforts. Basically, if by using the determined burn rate reduction that we talked about for this testing, there's actually the potential to use CFD, or computational fluid dynamics software, to model the potential reduced flame height and radiant heat of a hypothetical LNG pool fire. And this is another tool that specifiers and owners of LNG facilities could be able to utilize in the future, where not only can you implement the PFS system to get a reduced flame height and reduced heat associated with a pool fire, but there's the potential to be able to model that effect before you even install it and get a better idea as to what that reduced radiant heat looks like.
So the impoundment basins that we've been talking about come in many different shapes and sizes. So I was wondering, how do specifiers know how many modules they need if they want to incorporate this system within their facility?
Yes, that's a question we get from time to time. Basically, our PFS system is composed of individual modules of PFS. They come in 3 standard sizes, all of which are 18 inches wide by 8 inches high, but they're either 22, 24, or 36 inches long. So my job on our technical services team is to work in collaboration with facility owners or specifiers. I will get my hands on actual drawings and dimensions of the impoundment basin that a client may have, and I'll sit down and I'll design how many modules need to be placed and in what orientations, so that they come right up against the interior basin walls so that you have as much coverage as possible, but you still have enough gap around the perimeter so that if LNG were to be introduced, they have enough room and they can freely float to the top. So we are very hands-on with getting your drawings as a client and making sure that the right sizes and the right configuration of modules are used so that you have a clean and continuous PFS system applied at the end of the day.
So this sounds like a very different system to typical insulation products that are on the market today. Is it difficult to install, Alec?
It's surprisingly very easy. We have a comprehensive installation guide that we frequently hand out to customers interested in this system. It talks about the various steps that go into applying these modules within the bottom of an impoundment basin. Essentially, you're just laying down the modules based on the layout that we will provide, and then you're using a series of stainless steel bridges and screws to connect them all together into one continuous structure. So while I say it's not difficult, in fact, a lot of installation contractors have done it without any prior experience, we also offer the services of potentially providing training should you want just a little extra peace of mind, where we can either host a training session at one of our global training facilities, or we can come out and actually arrive at a project site during startup and work hand in hand with the contractors to let them know how to do things, observe activities, and make sure that the project gets off the ground running.
So we've talked a lot about fire safety in the context of LNG facilities. But Alec, is there one point you'd really like listeners to take away? And where can our listeners go to learn more?
Yes, good question. I guess if one point I'd like to leave with today is that an LNG spill within a facility is already a very serious issue. And if a facility were to run into the scenario of being unable to tackle, unable to extinguish that fire, that problem could become an even greater problem very quickly. So by utilizing safety systems like the FOAMGLAS PFS system, you can gain peace of mind that you're protected against your worst case scenario of an LNG spill becoming an even greater problem should a fire occur. If people would like to learn more, you can go to our website at owenscorning.com. We have product pages, demonstrations, videos on this system, and you could reach out to us directly as well if you'd like to talk one-on-one. We'd be happy to discuss your facility and our systems even greater.
Great. Thank you very much, Alec. We really appreciate your time today.
Thank you, Callan, for having me.
That's all for today's episode. My thanks again to Alec Cusick at Owens Corning for joining us and sharing his expertise on LNG fire safety and insulation performance. If you'd like to learn more, our sister publication, LNG Industry, recently hosted a webinar with the team at Owens Corning, exploring considerations and priorities during cryogenic liquid spills at LNG facilities. You can access this webinar for free by heading over to lngindustry.com/webinars. Thanks for listening to the Hydrocarbon Engineering Podcast. Subscribe for free wherever you get your podcasts. And if you have enjoyed this episode, please rate and review and forward to a colleague or friend.
The Hydrocarbon Engineering Podcast is brought to you by Owens Corning FOAMGLAS Insulation. From managing vapor drive and mitigating corrosion risk to maintaining thermal performance and supporting safety on the job site, the insulating system plays a critical role in high-performing hydrocarbon processing facilities. Learn more about how FOAMGLAS insulation contributes to the design of high-performing insulating systems at cryogenic facilities at www.owenscorning.com/FOAMGLAS LNG That's www.owenscorning.com/FOAMGLAS LNG study.